You can build a wall out of dirt, sand, and straw for about $40 in materials, and it will keep a room cool through a summer that would have you running an air conditioner in any modern house. There are houses in the west of England built this way that are over 500 years old, still lived in, still standing, with people paying good money for them. And here's the honest part stated up front, because that title makes two large claims, and I am going to deal with both of them now rather than at the end. The $40 is materials. Clay subsoil is free if you have it. Sand is cheap, and straw is a few dollars a bale. What it does not include is the labor, and the labor on COB is enormous. This is the cheapest wall in the world to buy, and one of the most expensive to build, and the currency is your own time. The second claim is bigger, and it is the reason this video exists. COB is not insulation. I know that sounds like I have just undermined the whole thing. I have not. But it is the single most misunderstood point in earth building, and if you get it wrong, you will build a wall that makes your house worse rather than better. I'm going to show you exactly what COB does, why a 500-year-old Devon cottage stays cool in August, the honest map of where this works and where it fails, and the one thing about it that decides whether you should build one at all. 2 summers ago, I stood inside an old earth-walled building on a genuinely hot afternoon, and the difference walking through that door was like stepping into a cellar. The thermometer outside read the low 90s. Inside, it was somewhere in the low 70s, with no machinery anywhere in the building, no fans, and windows that had been shut since morning. And then I went back to the same building on a cool morning a few days later, and it was still in the low 70s. Barely moved. That is the whole video, and I'll come back to it. Here's precisely what a COB wall does. It stores heat in enormous quantity, and it releases it slowly. That's it. That's the entire trick. A thick earth wall takes hours upon hours to warm up. When the sun beats on the outside face all morning, that heat does not arrive in your room at midday. It creeps through the wall slowly, and it arrives late in the evening, by which time the outside air has cooled and the wall is losing heat outward again. Engineers call that thermal lag, and in a wall 2 feet thick, it can run to 8, 10, 12 hours. So the wall does not keep heat out. It delays it, and it flattens it. The peak of the afternoon never reaches the inside of your house as a peak. It arrives as a gentle rise, hours later, spread out and blunted. Here's precisely what it does not do, and this is the part I promised you. It does not resist heat flow well. Its R value, which is the number that measures resistance to heat passing through, is genuinely poor per inch. A 2-foot COB wall has a lower insulation value than a modern insulated stud wall, a fraction of its thickness. Those are two different properties, and they get confused constantly. Insulation slows heat down permanently, in both directions, all the time. Mass does not slow heat down. It absorbs it, holds it, and lets it back out later. So, a COB house in a climate where the temperature swings widely between day and night is superb because the wall is constantly absorbing the day's heat and dumping it into the cool night over and over. And a COB house in a climate where it is hot, day and night for weeks on end, will eventually saturate. The wall charges up with heat, never gets a cool night to discharge into, and after several days it stops helping and starts radiating heat at you from the inside. Everything about where this works comes from that one sentence. Cost? Clay subsoil is free if it is under your feet, and it is the material you dig out for a foundation anyway. Sand is $20 to $40 for a load. Straw is $5 to $10 a bale, and one bale goes a long way. Water is water. So a small wall genuinely lands in the tens of dollars, and a whole house is in the hundreds rather than the tens of thousands in materials. Then there's the labor, and I'm not going to soften this. COB is mixed by foot or by tarp, carried by hand or by barrow, and placed by hand in lifts of maybe a foot at a time, with days of drying between lifts. A COB house is a season of work, or several, and traditionally it was built by a community rather than a person. That is the honest trade. Almost no money and an enormous amount of time. I spent a career maintaining buildings, and the thing that struck me most about the old earth buildings I have been in is not how well they perform. It is that they are still there. We have a habit of assuming that anything built without modern materials is temporary. And then you stand in a house built out of dirt and straw during the reign of a Tudor monarch, with people living in it, with the original walls still doing their job, and you have to adjust. Those buildings did not survive by accident. They survived because the people who built them understood 2 rules, and I will get to those, because they are the difference between a COB wall that lasts 500 years and one that dissolves in 5. So I'm going to walk you through the whole thing in order. The material, the mix, the test, the 2 rules, the map of where this works, the code situation, and the honest limits. And then I'm going to give you the part that ought to interest you, which is that COB did not die out because it failed. Before that, it is worth knowing how widespread this was because people tend to assume earth building is a regional curiosity. It is not. It is arguably the most common building method in human history. Devon in the west of England has thousands of cob buildings still standing and still occupied, a great many of them 500 years old or more, in a climate nobody would describe as dry. Across the American Southwest, adobe, which is the same idea formed into sun-dried bricks rather than built monolithically, built entire towns, and some of those structures have been continuously occupied for centuries. In Yemen, at Shibam, there are earth tower houses standing several stories tall, built centuries ago, in a city sometimes described as the oldest skyscraper city in the world. Across North Africa, the Middle East, parts of China, and much of sub-Saharan Africa, earth building was simply how buildings were made, and enormous numbers of people still live in earth buildings today. Estimates commonly put the share of the world's population living in some form of earth structure at around a third. So this is not a fringe technique that a few enthusiasts revived. It is the mainstream of human construction, which the industrialized world stepped away from within about a century and then forgot it had ever used. There's no money in it, obviously. You cannot sell a service contract on a wall made of dirt. Nobody manufactures it, nobody ships it, nobody's living depends on it, and there is no product to advertise. But that is not the main reason it disappeared, and I will come to what is. The main reason is labor, and specifically what happened to the price of it. Cob was normal when building materials were expensive and human time was cheap. If you were a farm laborer in 1600, you did not have money for cut stone or fired brick, and you did have a family, neighbors, and a slow season. The dirt was free and the work was yours to give. Then came fired brick at scale, then cement, then the railway to move it, and then a century in which wages rose steadily. Every one of those changes moved the balance further in the same direction. Materials got cheaper and faster. Labor got more expensive. At some point in that century, the arithmetic crossed over, and a wall you could build in 2 days out of purchased blocks beat a wall that took a season out of free dirt. Nobody banned cob, and nobody argued against it. It simply lost, quietly, to the clock. And that is why it is coming back now among a very specific group of people, those who have more time than money, or who value the building itself rather than the schedule. For everybody else, the arithmetic still points the other way, and it is honest to say so. If an old maintenance man's tricks are worth your time, hit subscribe and the thumbs up. It's the only way I know that you want more of them. Now the material, in plain talk. Cob is subsoil clay, sand, straw, and water, mixed together and built up by hand into a monolithic wall. No bricks, no blocks, no forms, no mortar joints, because the whole wall is one continuous piece. Each ingredient has a job. Clay is the binder. It is what holds everything together, and it is why you dig down past the topsoil to find it. Topsoil is full of organic matter and it will rot and shrink. Sand is the aggregate. It gives the mix its bulk and its compressive strength, and it limits shrinkage. Clay on its own cracks badly as it dries, and sand is what stops that. Straw is the reinforcement. It works in tension, running through the mix in every direction, exactly as steel does in concrete, and it holds the wall together against cracking and against the small movements a building makes. Water is what makes it workable, and less is generally better than more. The proportions depend entirely on what your soil is, which is why the first thing anybody does is test it. The test is genuinely simple, and it costs nothing. Take a jar with straight sides, fill it about a third with your subsoil, top it up with water, add a pinch of salt. Put the lid on and shake it hard for a couple of minutes, then leave it standing for a day. It will settle into layers. Sand and gravel fall out first at the bottom. Silt settles above that, and clay settles on top, often taking many hours to clear. Any organic matter floats. Measure the depths of those layers, and you have a rough breakdown of what your soil is made of. Now you know how much sand you need to add, and whether your subsoil is workable at all. Then do the second test, which is the one that actually decides things. Mix small trial batches with different proportions of sand to soil, roll each one into a sausage, and gradually push it out over the edge of a table until it breaks off under its own weight. A mix that crumbles immediately has too much sand. A mix that hangs on for a long way and then droops has too much clay and will crack as it dries. What you want is one that reaches a few inches out and then snaps off cleanly. Make a few small bricks of your best candidates, let them dry in the sun for a week, and then look at them. Cracks mean too much clay. Crumbling at the edges means too much sand. Drop them from waist height and see which survives. That is a week of work with a jar and some buckets, and it is the difference between a wall that stands and a pile of dirt. Now the mixing and building, briefly, because this is where the labor lives. Traditionally, cob is mixed on a tarp, with the ingredients piled on and then rolled back and forth by pulling the corners, or mixed by treading it underfoot. Both work and both are hard physical work. The mix is then placed on the wall in lifts, meaning courses of perhaps a foot in height, worked together by hand and foot, so there is no joint between the new material and the old. And then you stop and you wait. Each lift has to firm up before the next goes on, or the wall slumps under its own weight. That waiting is why cob is measured in seasons. The walls are trimmed back with a spade once they have firmed but not fully dried, which is what gives old cob buildings their smooth, flowing shape. Now the two rules, and these are the entire reason those Devon cottages are still standing. The old builders said a cob house needs a good hat and a good pair of boots. The good hat is a roof with a generous overhang. Cob's enemy is water, and specifically running water down the face of a wall. A wide overhang keeps rain off the wall, and every surviving old cob building has one. The good boots are a stone or masonry foundation, or plinth, raising the earth wall clear of the ground. Cob must never sit in wet ground, and it must never wick moisture up from below. Traditional buildings sit on a stone base a foot or two high. Break either of those rules, and a cob wall will fail, sometimes quickly. Obey both, and it will outlast you and your grandchildren. And there is a third rule that came later and has ruined a great many old cob buildings. Never seal a cob wall with cement render or modern impermeable paint. Earth walls need to breathe. Moisture moves in and out of them constantly, and a permeable lime plaster lets that happen while shedding rain. Seal that surface with cement, and the moisture gets trapped behind it, and the wall rots from the inside while looking perfectly fine from the outside. That is not a theoretical risk. It is the single most common cause of failure in historic earth buildings, and it was done with good intentions during a period when cement was regarded as an improvement on everything. Now the map, because this is what decides whether you should build one at all. Cob works best where three things are true. First, a large daily temperature swing, hot days, cool nights. That is what lets the wall discharge overnight so it can absorb again tomorrow. Deserts and high country are the classic case, which is why earth building is everywhere across the American Southwest, North Africa, the Middle East, and the High Plains. Second, a dry climate, because water is cob's only real enemy. Third, a temperate winter, or a willingness to add insulation, because mass alone does not keep a house warm through a long, cold season. And cob struggles where those are not true. In a hot, humid climate with warm nights, the wall saturates and stops helping. In a genuinely cold climate, mass is the wrong tool. You need resistance, meaning insulation, and a cob wall on its own will lose heat steadily all winter. Modern builders in cold regions get around this by insulating on the outside of the mass, which keeps the thermal store inside the heated envelope. And that is a good arrangement, but it is no longer a simple cob wall. And in a very wet climate, cob is entirely possible because Devon is not dry, but only with a serious hat and serious boots and lime plaster and proper detailing. So the honest summary is that cob is superb in hot, dry country with cool nights, workable with care in temperate, wet country, and the wrong choice on its own in a humid, tropical climate or a hard, cold one. Now the code, because you cannot build a house without addressing it. For most of the last century, cob had no route through building regulations in most of the developed world. It was not banned exactly, it simply was not in the code. And a material that is not in the code is a material a building official cannot approve. That changed recently, and it matters. The 2021 edition of the International Residential Code introduced an appendix covering cob construction, which, for the first time, gives it a genuine pathway in jurisdictions that adopt it. That is a substantial development, and it is why the current revival is different from previous ones. There is now something an inspector can point at. But adoption of an appendix is up to individual jurisdictions. So the first question for anybody serious about this is not how to mix cob. It is a phone call to your local building department. Now the honest limits, all of them. The first is labor, which I have already given you and will not repeat, except to say that it is the reason cob is rare, not the performance. The second is the mass and insulation confusion, which is the technical heart of this, and which I have covered. The third is thickness. Cob walls are 18 to 24 inches thick, which means a cob house has substantially less floor area inside it than the same footprint built conventionally. On a small plot, that matters. The fourth is drying time. You cannot rush it. You cannot build a full wall in a week, and a wet autumn can stop work entirely. The fifth is seismic performance. Unreinforced earth walls are heavy and brittle, and in an earthquake zone, that is a genuine engineering issue that has killed people in traditional earth buildings around the world. Modern earth building in seismic areas uses reinforcement and engineered detailing, and this is not a place for improvisation. The sixth is finance and insurance. Getting a mortgage or insurance on an unconventional structure is harder than building it, and a great many self-build earth projects run into that wall rather than a technical one. And the seventh is maintenance. An earth building is not maintenance-free. It needs its plaster looked after and its roof kept sound, and a cob wall left with a leaking gutter above it for 2 years will show you exactly why the old builders talked about hats. Now the safety section, which is short. The material itself is about as benign as building materials get. It is dirt and straw. There is no chemistry, no off-gassing, and nothing toxic. The genuine hazards are ordinary construction ones. It is heavy work and people hurt their backs. Wet cob is far heavier than it looks. Working at height on a wall needs proper access. And the structural and seismic questions are real, and they belong with an engineer rather than with a video, particularly for anything anybody will sleep in. So who is this actually for? If you have clay subsoil on your own land, a hot, dry summer with cool nights and time rather than money, this is genuinely one of the best things you could build. And people have been doing exactly that for thousands of years on every inhabited continent. If you want a garden wall, a shed, an outdoor oven, a bench, or a small outbuilding, this is an excellent first project and the stakes are low. That is where I would start, and it is where almost every experienced earth builder started. It is also worth knowing that cob is one of several earth methods, and one of them may suit you better. Adobe is the same material formed into bricks, dried in the sun, and then laid with an earth mortar. It suits hot, dry climates with reliable sun for drying, and it lets you make bricks in batches rather than committing to a continuous build. Rammed earth is a damper, sandier mix compacted hard into temporary forms in thin layers. It is faster than cob for large walls. It gives those striking horizontal bands you see in modern earth architecture, and it needs formwork and a compactor. Light straw clay is almost the opposite of cob. It is mostly straw with just enough clay slipped to bind it, packed into a framed wall, and it is insulation rather than mass. In a cold climate, that is often the more appropriate choice. And earthbag building uses bags filled with damp subsoil, stacked and tamped, with barbed wire between courses. It is fast, it is forgiving of poor soil, and it has been used extensively for emergency and low-cost housing. So if your soil test comes back poor for cob, or your climate points away from mass, the answer may well be one of those rather than abandoning earth building altogether. If you live somewhere humid with warm nights, or somewhere with hard winters, understand what you're getting before you commit a summer to it. And if you are hoping to save money on a house, be honest with yourself about whether you have several hundred spare days. So this week, here's what I want you to do, and none of it costs anything. First, dig a hole. Go past the topsoil, take a handful of the subsoil underneath, wet it, and roll it between your palms. If it forms a smooth sausage that holds together, you have clay and you are in business. If it falls apart, you have sand and you will be importing your binder. Second, do the jar test. 1 jar, 1 handful of subsoil, water, a pinch of salt, shake it, leave it a day, and measure the layers. That tells you what is under your land and almost nobody knows. Third, look up your average summer day and night temperatures and work out the gap between them. If your nights drop 15 or 20 degrees below your afternoons, mass is a good tool for you. If they barely drop, it is not. Fourth, call your building department and ask whether they have adopted the COB appendix. That one phone call tells you whether this is a project or a daydream where you live. And fifth, if it all checks out, build something small. A bench, an oven, a garden wall. Learn the material on something that does not matter before you build something that does. Tell me in the comments what your jar test looked like and what your summer night temperatures do where you are. I read every one of these, and those two things together decide whether this belongs on your land, and almost nobody has checked either. I'll leave you with the thing that has stayed with me since I stood in that old earth building on a hot afternoon. Those walls were built by people who had no machinery, no insulation, no engineering tables, and no choice about the climate they lived in. They used the dirt under their feet, and they got the roof and the foundation right, and 500 years later the building is still cool in August and still occupied. We did not stop building this way because it stopped working. We stopped because it takes a season and a community, and we found materials that take a fortnight and a crew. That was a fair trade for most people, but it is worth knowing that the older answer is still standing, still working, and still lying under your garden.